In this lesson, we're going to look at intersection and union of sets. And we've done some set notation, and we're going to look at one other type of set notation as well. So looking at intersection and unions. So when we talk about the intersection of two sets, A and B, we write that as A, and it's sort of like an N or a horseshoe. A intersect B is the set of elements that is common to both sets. So for example, A intersect B equals the set of all x such that x is an element of A and x is an element of B. We can show that using a Venn diagram. So if this is all of the elements of set A, and this is all of the elements of set B, then the elements of the intersection are the elements that they have in common. So it's where the overlap is in the diagram. So that would be A intersect B, that area. Okay, so the union of sets Okay, so the union of set A and B, A union B, is the set of elements of A or set B or both, okay? And can be written as A union B equals X such that X is an element of A or X is an element of B. And we can show that again with the Venn diagrams. If this is all of the elements in set A, and this is all of the elements of set B, then A's union with B is all of A and all of B and includes the area of overlap. So the whole thing is A's union with B, or A union B. So we can look at an example here. If A is equal to the set of 1, 3, 5, 7, 9, 11, and B is equal to the set of 1, 2, 3, 4, 5, 6, 7, then A's intersection with B will be which set of numbers? It'll be the set of numbers that they have in common. So that will be just 1, 3, 5, and 7. And we're using the roster method here where we list all of the elements of the set. So then let's look at A's union with B. Is the set of all the numbers that are contained in both. And it's very nice if you continue to put them in numerical order, going from low to high. So the set will contain 1, 2, 3, 4, 5, 6, 7, 9, and 11. We don't repeat the repeated numbers. We just write each of them just once. Okay, and a little reminder about our inequality symbols, less than and greater than, okay? And greater than. Think of them as pointing to the smaller number. So if we were to put the correct symbol between -1 and -4, we have to think which one is that. Is -1 greater than or less than? And it is greater than -4. Or we could write -4 is less than -1. If we have the symbol with a less than with a line below it, that means A is less than or equal to B. Okay, it can be either one. And greater than or equal to is a greater than symbol with an extra line as well. Okay, this is important. It doesn't have to be both. It's one. It can be one or the other. Okay, we've done roster notation where we listed the sets, the elements of the set, and we've also used set builder notation where we're using the curly braces and saying x, the set of x such that, and then describing what x is. This interval notation is a really nice, brief way of showing a set of numbers. It's only good for real numbers, though. You cannot use it for integers or natural numbers. Okay, you enclose the endpoints in brackets, and a round bracket indicates that the endpoint is not included, and the square bracket indicates that the endpoints are included. So I'll show you with some examples how we use those. So if I have two numbers a and b, and they represent two real numbers where a is less than b, and we always work from low to high using interval notation. So if I write this a, b, this is going to be the set of all x values such that a is less than x, which is less than b. Okay? A itself is not included, B itself is not included because of the round brackets. We can show this on a number line. If we put the values, show where they are on the number line, we can actually show the interval using the same type of brackets. Okay, so this just shows that we're including all of the values between A and B. The round bracket says we're stopping just shy of A and just shy of B. So an example using real numbers would be -3 and 2 would be the set of all x values such that, and here always work from low to high, -3 is less than x, which is less than 2. Okay, so when you've got the round brackets, you're always just using the less than symbol, not less than or equal to. So let's put a number line here to show this one. So if I put 0 here, -3 and 2, put a few extra values on there. To show this interval on a graph, I'll use a different color here. We're going from -3 to 2, so all of these numbers are included. So it's good to use a darker line or a different colored line to show the interval, and then put brackets at the end points to indicate what's included. This is called an open interval because the endpoints are not included. Let's look at another example. We're still working with A and B, where A is less than B. But let's use the square brackets this time. So I've got A, B in square brackets. This is equal to the set of all values x such that, and we're still going from low to high, A is less than or equal to x, which is less than or equal to B. So you always have your endpoints and closing x. We're always using the less than or equal to symbols when we're doing this method. Okay, so again, we can show this on a graph. By putting our values a and b on it and darkening or highlighting using a different color the line to show the interval between those two values, and again just putting the type of bracket at the value to show what the interval looks like. So if I do an example like this interval 5 and 13, that's the same thing as writing x such that 5 is less than or equal to x, which is less than or equal to 13. It's all of the values, every single value between 5 and 13, including 5 and 13. So again, on a number line, we could show this, again, maybe using a different color. We're going from 5 to 13, and we put a square bracket on to show that we're including the endpoints. And this is called a closed interval. Because the endpoints are included. So the only difference between these two intervals is the shape of the bracket and the inequality symbol in the description. There's one more type of interval to look at, and that is an infinite interval, because sometimes we're talking about just all of the values above or below a certain number. So for instance, if I have the interval a to infinity, infinity always has to have a round bracket on it because infinity is not a defined number. And this would be equal to saying x such that x is greater than a. Because a had a round bracket, I need the greater than symbol, not greater than or equal to. And notice that I don't have a low and a high. We would never write a is less than x, which is less than infinity. Okay? We don't write that. We just say it's all the values greater than a. So on the number line, pull that one down here. Oops. On a number line, then we will have the value a, and to show that interval, we use, because a has a round bracket here, we put a round bracket, and we draw an arrow to the right, showing that it's all the values to the right or greater than a. And we'll do one more example, and that's when we're going from thinking of all of the numbers that are less than a particular value. So we could have something where we're going from negative infinity to b, and let's use a closed symbol on the b there. So that represents everything that's less than b, but also it includes b because of the square bracket. So that's a set of all x such that x is less than or equal to b. These two intervals are called infinite intervals because they go on forever. And we can show this one on a number line. There we go. Let me just get rid of that one. All right, so we've got b on the number line. And we show the interval with a closed bracket because the original has a closed bracket, and we highlight or darken or use another color and show an arrow going to the left. So it's an infinite interval going to the left. Okay, we'll do a couple of examples of going back and forth between interval notation, set builder notation, and creating a graph as well. So in this example A, we've got -3, 4. It's open on the left, closed on the right. So that will be the set of all values of x such that -3, because that's open, is less than x, which is less than or equal to 4. So there's the set builder notation for A. On the number line, There's 0, 4, -3, etc. And so we're going from 3 to 4 with a square bracket on the 4 because it's included, and a round bracket on the 3 because, or the -3 because -3 is not included. So let's look at B. We're going from -1 to, and that will be an infinity there. Okay, so that's the set of all x such that, notice that it's rounded here, x is greater than -1. Okay, so to sketch that one, we use a number line. It's helpful usually to place 0 as a value on the number line and then include some of the other, just to show that you know how to count here, show that the -1 is to the left of 0, for instance. And you're going to go to infinity, which is always going to be to the right. We're not including the -1, so we'll use a round arrow, and we show that it's, make sure that it's clear that you've got an arrow, that this one goes on forever. Then let's look at C. I'll just rewrite it down here. It's a closed interval from 2.5 to 4. So on a number line, we may have to do something like this. Okay, where we're showing sort of the midpoints between values as well. Again, this one's a closed interval, so we'll use the square brackets, and we're going from 2.5 to 4, and darken, use another color, something to show that interval standing out from the number line. And that's it for this lesson. So now when you're working with sets, you might use set builder notation, which uses the curly braces, or you might use the roster method to list the numbers that are in the set. However, you now have a third method, which is interval notation, which is fastest and easiest way to show a set, but also only works for real numbers.